This is stream number 28, and my name is Raimu, and I am almost done making this keyboard. Just finished all the soldering today, so all the keys and all the underglows. So just to demonstrate, watch what happens when I press this test key. Look, they all light up. Press this one over here, these all light up too. So rather than just having it flash white when I press this key in the corner, I think I would like... Hold on. Before I say the next thing I was about to say, I wonder if the keys I was hitting actually were screwing up anything in OBS. What does B do and what does J do? Hopefully nothing. I think I got in trouble doing that before, where I had OBS focused and then I start playing around the keyboard and it's like pressing something. So yeah, okay. Let's move to another window. Yeah, anyway. Can't notice anything on stream at least? Yeah, okay, good. Hey there, Lyndon. So I want to work today on, first, I want to change it so that instead of this key being the test key, I want to have it so at as we press each key, it lights the key under it. And then what I'd like to do after that is I would like to make it so that when you press the key once, it just lights up a little bit like bluish. And if you keep pressing the key, it goes green and then gets basically a heat map. So the more you press the key over time, the more light it goes from blue to green to yellow to red. And then when you stop pressing the key, it kind of decays back. So sort of like a rolling frequency counter for every key that's used to like look up a color in like a color curve. So that's the end goal, and I think that's where I want to leave the LED stuff. Well, I also need to figure out what we're going to do finally for these onboard LEDs here. I don't think I need them to blink anymore, for one thing. I do want to have it distinguished between several different states. So we'll have it off if it's passive. Maybe turn it to green if it is connected to USB. And maybe pick another color like maybe blue if it is connected, if it's receiving instructions over this cable. So in other words, it's the right hand side. And then the other colors I already have defined are white if it's receiving new firmware update, purple if it's forwarding firmware update, and red if it's programming. So actually maybe that's what I should do first. Let's find the code where I actually do that blinking and remove it. Was that an LED? No, that's just setting the color. I guess we can just see where that's called from. There we go. So there's an LED blink state. We can remove that, right? Don't need that anymore. Try to use the new keyboard as much as possible. Well, I just hit a Control N. I want to do Control left arrow. All right. Blink LEDs. We're going to get rid of this completely. I don't think I need to do any LED blinking at all. Okay, then set color isn't called at all. That's not right. It is called, so I think it just lost its context. There we go, we're back. Okay. Yeah, so the normal state, I think we want to have like 3 different modes for this. It should be depending on if the USB is configured, then one color, else if we've received a greeting message, and then if neither of those is true, I think we're just gonna make it black or off. So delete this code here. Let's make it green on the right-hand side once the USB is configured. And let's make it blue if it's received a greeting. I do want... Okay. I was about to say I do want to distinguish between off and on, but we already have this solid green one that I can't control when it has received power, so that's good enough for me. I think I'm going to leave it like this. I wonder why this firmware upgrade one is here. Because don't we control that in Programmer? This is purple if it's forwarding the program. This is red when it's completing the firmware update. So where do we change it? So I guess that is fine. We're changing it to white here. Where is this called from? Oh, if we don't have a programmer. Is that if we don't receive a new programmer? I think this is always returning us a programmer, right? This is a little weird. I'm having trouble reading this now. Past Rami, what were you thinking? Okay. I think it's fine. Let me just build and program it. Make sure that the lights are correct now. Nope, I have an error somewhere. Oh, blink LED. Yeah, we don't need to call that. And this thing we don't need anymore either. Yeah, don't need this. Which means we don't need was USB configured. And we probably don't need a couple other things. But I have some errors to fix. Yeah, get rid of that. Alright, and then, yeah, we don't need this blink interval. It should have said I don't need that. Where is that still used? Ah. Yeah, we don't need this timer anymore, do we? Yep, and then we don't need this. Okay, I'm surprised that it didn't tell me I didn't need the blink timer anymore. We can write something better here. This is how often the primary board sends a greeting to the secondary board. I'll need to comment those maybe next time we refactor. But yeah, I shouldn't find the word blink anywhere. What about timer? I thought I had a NeoPixel timer just now. And I don't remember removing it. I guess I must have. Let's look at the diffs. LED blink states removed, was USB configured. Okay. Okay, that took a NeoPixel blink timer. Oh yeah, and I deleted it there. Okay, then we should be good. All right. So we should have no more blinking, and it should be green on here and blue on here when we're done. Don't know if I'm ever going to get to the bottom of this one. This is that figure out why it sometimes takes 30 seconds to connect. I don't know why. Okay, we're working on this one today. I don't know if I'm going to actually stream that one. That's going to be like stuff I do off stream. And we can delete this now, right? Oh, hold on. I don't want to press anything while it's programming. There we go. They're stuck red. Am I not calling the function to actually set the LED state? It's possible, because now they're stuck red. Okay, we'll have to fix that. Keyboard's obviously working. It's just stuck on red. Yeah, I want to delete this one, because we're done with that. Yeah, and then we can delete this now. Everything else should be done. Okay, try to make use of the second CPU core. I actually don't even think I need to do that. Although it would be kind of cool to figure out how to do that at some point. I don't think I'm going to worry about it now, because I actually timed how long it takes to like turn on all the LEDs like that. And it only takes like half a millisecond. So, and we're not going to be changing the LED state any more than like once every 40 milliseconds anyway, so I don't think it's a big deal. Yeah. Alright, now why isn't it lighting up my LEDs? LED, set color. So reflect color state, controller state is not being called. The right point, apparently. Oh, it's only when we receive a new message? Okay, then, this function really doesn't need to exist anymore then. Hey there, Sarian, how are you doing? And Velusip, how are you? Half a millisecond, how much data do you send? It's 24 bytes times 18. Or 24 bits times 18. So whatever that is. I'm not very good with math. 24 times 18 bits. So 432 bits. So I guess each bit is about a microsecond. The datasheet probably says for sure. I mean, I could have figured this out ahead of time, and then I wouldn't have had to worry about how long it takes. Near the end, they have like protocols for the time here. Yeah, so maximum of 1 microsecond for a 1 code high time. So yeah, it's on the order of 500 microseconds for all the bits I need to push through. Feels like it shouldn't take that long. It's just the speed at which these neopixels communicate. But 500 microseconds is no big deal. The keyboard just needs to... Its primary loop needs to go once every 10 milliseconds. So half a millisecond is nothing. Okay, yeah, I think we want to do away with this. Essentially, we're going to have it turn white at the moment that firmware update is set. So let's just place it where it belongs, right? Let's go and search for that and see where it's actually set. So it's set right there. Right here. So we'll just Have it change the LED state right there. Except for we don't have self here. Is that why? Okay, then we're gonna go to the caller. This one. Actually, I can see it's right there. Right, and then that's called by next. Right here. Okay, so I see what's going on. It's only going into, if it's going to the else. So really this should be if let was it controller state? Firmware, I don't care, equals borrow a controller state. Do that. Okay. Now I'm going to want to set it to green somewhere else. That would be whenever the USB becomes configured, right? So when do we know if it's configured? I suppose we would check that every time we poll the USB. Oh, and I had a flag called was USB configured. I ought to bring that back, actually. Yeah, let's bring that back. This one. So I'm going to revert selected changes, bring that flag back. Save all. Guess it doesn't need to take that long. Well, I mean, it could go faster if the chip was faster. Okay, so bring this line back. Okay. I'll bring this one back just for a moment, but I'm immediately gonna change it. I think we want to call it every time a poll happens. Yeah, that's what I'm gonna do. I think I want to combine this with no, take that back. I was about to say combine it with the greeting, received greeting, but I'm not going to do that. Okay. So yeah, let's take this out. So this really belongs down here in this function, right? If it's configured and it wasn't before, set it to green. If it was configured and it no longer is, then it really depends on if we received a greeting or not. I guess what we can do is we can just go back to off, and we can reset the self received greeting, because we can just wait for the next greeting, right? Yeah, so then I just need to have a place where when we receive a greeting, we would change it to blue. Ah. There you go. Alright, so I'm gonna need one of these, but make it blue on received greeting. So let's look for this. I'll change that name of that function in a minute. Here it is, right here. So change it to blue. Cool. So let's go back and change that name of that function. What's this complaining about? It is red. Oh, because that function isn't called anywhere. Right, so there are no references to this. So let's make this function the correct name. Update. Ah, I hit the wrong key. not update LED blink rate, it's update LED. Really, it's update controller LED. Can't type. There we go. I'm like confused what layer I'm on. Are both keyboard halves listening for modifier keys from each other? This one is listening for modifier keys from this one, but this one is combining the key presses on its own board with those that it receives from this board. So they're kind of being joined here and then sent off to the host. So, and modifiers can come from a couple different places. It could be built into a key's meaning, and it could also be a one-shot modifier. So there are a couple different sources of modifiers. They all get decided upon on the left-hand side. The right-hand side really is only listening for when this guy says to light up his LEDs. And what else does he listen for? Oh, he's listening for firmware updates. Actually, I can show you that. It's in polling, poll peer serial. So, okay, this is what the left board is listening for. It's listening for key presses and log messages. And the right-hand side board is basically treating the left-hand side as if he was the host. And so these are the things that the host can say. Greeting, which means that to confirm that he is a right-hand side board. So all I'm really doing is just setting a flag and then changing the LED state. It can be told what to set for the underglow LEDs. He can be given new key configurations, or it can go into this state machine, which is used for firmware updates. So like if you receive a firmware update command, I don't know why I buried this so many levels down. I could probably clean this up at this point, right? We probably don't need a separate method for all this stuff. Like, this state machine probably doesn't need to exist, right? Like, there's only two states, right? I probably don't need controller state anymore. I thought I did, but I don't think I really do. So I could probably fold this into here, so where if we receive a firmware update message, we get a programmer set up and all that stuff. Does yours transfer the key layout to the slave side? No, it's only kept on this side because this guy's only relaying debounced key presses and releases over to here, and this one keeps track of the key queue, the output queue, and so it has all the brains to do all the one-shot mods, the hold versus tap, and all that other stuff. Comms are via USART, or right now it's UART. Had a couple choices for this Raspberry Pi microcontroller. Could do SPI, it could do UART, it could do I can't remember. There are a couple other formats, other kinds of hardware protocols that we could use. I just picked UART because it's simple and it's good enough. Thinking that you don't think you could use the keyboard config like that, since you tend to hold modifier keys with the opposite hand of the modify key. It would need to be bidirectional. So what I do for the modifiers is the home rows double as modifiers. So if this key, if I press it, is N, but if I hold it down, it's Shift. And I do it to shift the left-hand side keys, right? Now those are capital. And then the right-hand index finger, if you press it, is T, but if you hold it down, it's a shift for the right-hand side. And same thing with layers. Like this one, if I hold it down, now these are numbers. But this layer has very few keys over here because it's sort of weird to hold a layer and then press with another finger of the same hand, right? So another thing is, like, all the navigation is on the right-hand side, so the layer for that is on the left. I didn't come up with most of this. This is from the Miryoku layout from QMK, and I started with that as a base, and then I modified it to suit me. Resolved in post. If you're saying modifiers on opposite hand, I resolve it in my layout. If you're talking about resolving the two keys together, it's all merged onto this hand side, figured out, and then key reports are generated there. Okay, what's the last change I made? All right, so that sets it to green, to blue. Right, so we're still not calling this guy. So I think we're going to call it from poll. Poll USB and then poll serial. Probably here's the best place to do it. Update controller LED. Okay, still have one warning. Oh, right. We don't need this function anymore. So let's delete it. So we don't need this else at all. Alright. Can you guys hear my neighbor's dog? He barks every night. It's almost like he's barking at the moon. That's right, Sarian. A squared C would be another one. Also, what's the other one that starts with an I? I squared S. I think it also supports I squared S. Look at there, Nightshade dude. You can hear the dog, huh? Okay, so if I got it to work right, this should light up green, that should light up blue. And I can like unplug this guy and plug it back in, and it should go from dark to blue within a second. Ba-da, ba-da. Yep, okay, green and blue. So I unplug this guy, plug him back in. Yeah, and then he turns blue within about a second. So that the blue confirms that he's received the greeting message from the other guy. Kind of confirms that the communication is working at least in one direction. All right. We don't need to see that. I don't know why Control-C doesn't break out of that right away. But yeah, now it did. Okay. Let's check this in before I go any further. So, change controller LED meaning. So, remove blinking. Green now means USB configured. Blue now means received greeting on UART. I think that's it. I don't think I changed anything else. Okay, so I have the controller LED squared away. The underglow LEDs, oh, I had them white for testing. I want to change that back to green. I had all these LEDs set to white because I did a max current measurement with this thing. So, like, if I turn on caps lock and I turn on both of these at once, right now my current meter says 200 and it's going between 0.28 and 0.26 amps. So that's because of the brightness level we set. I've actually tried cranking the brightness all the way up to max, and I actually reach a current limit of around 660 milliamps on my PC, and then on my Mac, it actually cranks out 2 amps for a few moments, and then it drops it quickly down to like half an amp and browns out my board. It's kind of scary. It's like they start off white, like you see here, really, really bright white, and then all of a sudden they change to yellowish and dim. I think it's just there's not enough current being, or the voltage level is dropping, and not enough current is going through the individual LEDs. They're all being, the max current, which is capped, is now being spread out. So I'm reducing the brightness to something reasonable, and then keeping out what you want to do is keep the amount of current on a USB device like this under half an amp. If it was USB 3, I read that you can go up to like 3/4 of an amp or something. And right now, I measured the hottest I can go is like Yeah, between 260 and 320 milliamps. So we're in good shape. All right, enough talk. Let's change the back LED color to green. So that's done where? Processing, I think, right? Where we receive a host report. Yeah, here it is. So this was only white for testing. I wanted to put it back to green. I like green for caps lock. Quickly verify that, and then we'll move on to the main event for tonight, which is instead of the test where like pressing one key lights up all the keys, I want pressing a key just to light up the LED under that key. It's a little bit interesting because the order of the LEDs is not the same as the order of the keys, because to make the routing easier. So this down here is key 1, which goes with diode 1, but it's NeoPixel 18. So the keys go 1, 2, 3 along the bottom, and then 4, 5, 6, 7, 8, 9, 10, 11, 12, like this, like left to right, top to bottom. But the LEDs start here and go down and up, and they kind of snake around, and they go end here. So that was just so that we didn't have as many signals crossing. So I'm going to have some kind of mapping between key number and pixel number, and use that mapping, right, to light the LEDs. And we'll probably want to have like an array of lights, of key light states. Well, woof, 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 I know. Let's stick to the dog right outside the window. Okay, let me check this in. Oh, verify. A nice green glow. You see that when I turn caps lock on and off? Okay, illuminate under glow LEDs green on caps lock. Okay, so eventually it's going to be a much more complicated state, but right now it can just be a simple, it could be a simple state of just having the color in it. So let's start with that. I think I should have a new module here called key LED. Ease. And actually, to make that separate from LED, I think we're gonna I'm going to rename this one to controller LED. Beep beep. Sure. Save all. What did it actually change? Oh, I see. Okay, I want to rename it inside of controller LED then to controller LED. Thank you for that follow. I appreciate it. Hope you're enjoying the stream. I'm being raided by Mr. Sir, CM Griffin. Hey, check out my new keyboard. Chris, I don't know if you remember, but I was I've been working on this for the last month. So I designed and built this keyboard. Here's the circuit board design. I can turn on the circuit traces to make it look even more impressive. And I didn't mean to turn that on. What am I doing? Oh, just turn that off. Okay. Design the circuit board, design the 3D models for the plastic pieces, 3D printed them, and I'm using Cherry MX brown switches, and I'm doing all the firmware in Rust. So let me know if you have any questions. Well, thank you. Thank you, Chris. You're the first one to actually mention my haircut. I'll have to tell Mrs. Raimu that you were the first to notice it. All right. So yeah, today I'm working on, my goal today is to make it so every time I press one of the keys here, that it lights up the LED under it. I soldered the LEDs earlier today. I think I was telling Chris this while he was streaming. I was telling someone while they were streaming. I don't forget what stream I was in. But to test them, I just have, if I press this key, it lights up all the key LEDs on that side. So if I press this one, it lights them all up. So verify that they're working, but right now they're all just being lit up together. And I want to make it so that they're only lit up when the key above it actually is pressed. Very trendy and hip. You just have crazy person hair. I got it from my dad. I think I also inherited my dad's hair, which is fortunate because balding runs in my mom's side of the family, and so does gray hair. So I don't have as much gray. You're already rating, so I should have had your ending screen up? Okay. Can you shout out Coding with Strangers? Of course you can. Please feel free. I will try to keep up with chat if you guys have any questions. The shout out command actually doesn't work. I'm sorry about that. Because that was my old bot, and the old bot is no more because it's part of the game, which I had to take down. Long story short, don't have a shoutout command. But we can just type twitch.tv/coding with strangers. There we go. There's a shoutout. Okay, so I know you guys have lots of questions, but you're too afraid to ask, so I will just give you a few links. I have all the information about the project I'm working on at that link. It's really just a shortcut to this notebook, and it explains who I am, what I'm doing, what my inspiration is, what my goals were, and all that stuff. But if you want to, I can just answer any questions you have. And the what this keyboard is based off of is a controller board made by Adafruit called the KB2040, and that uses a Raspberry Pi 2040, which is Raspberry Pi's first microcontroller. So it's really cool, but basically what it turns out to be, we use the general purpose I/O pins from the controller to connect to the keys, and we use a standard key matrix scanning technique to figure out when keys are pressed and when they're released. And our goal is really to just take those key presses and releases and turn them into reports for the host. And that was working a while ago, so we're working the last week on making the lights work. The lights are really just icing on the cake, so to speak. So one thing we use the lights for, like if the caps lock is on or off, the underglow LEDs come on. That's what those look like. So it's kind of hard with all the light here, but like if I hold off to the side, you can see that there are 4 of them, and they're green right now. So that's done, but today I want to, like I said before, I want to make the keys under the LEDs light up as I press them. Did you fabricate any keys, your keyboard yourself? I fabricated all the clear plastic pieces. So holding that up to the camera there, this bottom piece I fabricated, just PLA plastic on a 3D printer, and there's like a, it's hard to see, but there's a thin plate that holds the switches in place, and that's also 3D printed, and I designed that on stream in Blender. Oh, and there's also a cap. So I didn't have this at first, and people are like, well, what happens if like you spill something on the controller board? I'm like, yeah, it's probably not good. So I designed and 3D printed this little cap piece. And that turned out really well, I think. And you just slip it on, done. Love. Do you stream? Okay, got it. Okay. You have a gaming stream, but radio the coders instead? That's fine. Recently received some GPU accessories for your Pi. Gonna try to break open this cheap claw machine you got and try to drive within your Pi 400? Yeah, I mean, Raspberry Pi is a great platform. It's kind of just like an Arduino is a great platform for doing all kinds of general purpose stuff. All right, so I was in the middle when I got rated of renaming this struct controller LED because we want to distinguish these LEDs that are on the main controller board with the ones that are under the key, under each key. So I renamed that. Okay. save everything and see if what compiler errors I have. I don't think I have any. Okay, I want to rename this one to controller LED, and then I kind of like keeping everything sorted, so I'm going to put it up here. Hope you guys don't mind. And we need to actually have the definition match that, so that will be around here somewhere. Wait a minute, it is matching it. Oh, because it's not saved. But if I save everything, it should match again, right? Cool. So, make sure I can still build, and we're going to keep going. All right. So, I was going to make this key LEDs module. So, to add a module in Rust, go to the parent module, and go to the near the top, past the uses is where I usually put it, and say mod key LED. Well, thank you for the follow Coding with Strangers. Appreciate it. Okay, key LEDs. So, I think what I'll do is copy some of the stuff I did in one of these other submodules of keyboard. Yeah, because this thing, I don't want to have to type from memory. So we're basically adding more methods to my keyboard class. And if I do a use super that, because I am sort of lazy, it will know what a keyboard is. Okay, so let's define some functions. This is going to, we're going to be tracking the colors of LEDs, but let's have a function to actually update the LEDs. Update key LEDs. I don't think I need a mutable reference to self. What is up with my typing tonight? Okay, and right now, where we're doing the test of the key LEDs is in processing, I think. It was in handle key presses and releases. Here it is, hack. So here is how we actually update all the key LEDs. It's hard-coded that we have 18 per side and the brightness level is 32 and all that. So let's just pop it right there. Okay, we need to import smart LEDs brightness. We need to import repeat for now from core iter. And I think we'll just make the color hard-coded. Where was that again? It's under polling, sure, but where? No, here. Why is it not going there? Oh, because I'm in the wrong place. Processing is where it should be, yeah. Yeah, I think we're just going to make the keys white for now. So we'll hard code this, well, I say let color equal, and then it's obvious what we're talking about. But I guess RGB, everyone knows, is a color. Okay, so this we should make a constant. Alright, so then const, what to name this constant? Actually, we don't need to name it. The parent one has this, right? It's rows times columns. So it's num keys per side. Yeah. So that should be num keys per side. Don't need a constant here. I already have one. Just import. Can't import it? Probably because it's not exported. Because it's not public. Now it is. Now I can import it, right? No, still can't. Is it because the type is bad? Yeah, it has to be a U size. Rust is picky about types. Okay, now what? Probably because I'm missing some import. Oh, it needs to be mutable? Okay, fine. Self needs to be mutable in order to change the switch LEDs. I call them switch LEDs? That's inconsistent, isn't it? So let's make it consistent. Let's call this switch LEDs. Beep beep. Beep beep indeed. And then we're going to rename this one update switch LEDs. There we go. All right, so that means that this should be calling another one, right? Processing. This is where we make this decision, right? Handle key presses and releases, so we'll just make it official, call self.update. Oh, I forgot to make it public. That's why it's not showing up in the list. All right. Update switch LEDs. There we go. So I can remove all this stuff. Hold on. It's this key state debounce we'll want to know, right? Yes. In fact, we'll want to know that before the previous one, so let's do that. What type is that? That's probably U64. Yep, because we have up to 64 switches. U64. Right. I think I want to do the same thing as I did where is it? In was it here? Well, I guess we're just comparing the current state and the previous state, right? We're using that. We're going to use that to update the colors in the list. Okay, so I'm going to need some colors in that in the state here. Let's just call it switch LED colors. So we know exactly how big it is, right? So it can just be an array of RGB 8, and it's going to be a number keys per side. Actually, that's not true. It's going to be we want to hold on to the all of the number of keys total, right? We're going to use the first half to light our own keys up, and we're going to use the second half to tell the other guy what to light up. Okay, and this has to be as U size, because Rust is a pain. About types. Okay, so init, we need to initialize it. So RGB 8 new, right? And just 0 for all these. And then again, num keys total as U size. What an initializer. Okay, back to being good. Right, so then we can remove this hack then. Okay. So now I've reduced it. Oh, there's yeah, right here. I've reduced it to that we have the new state, and we know the previous state is in self. We want to see where they're different. So I think that means I want to do an exclusive OR of the two, and we can return right away if there are no changes, right? So let keys changed. equal key state debounced exclusive, or is that key self dot previous key state debounced. Okay, and then if keys can't type, let autocomplete work with me, equals 0, we can return early. And that's where most of the time the code is going to flow through that return. We'll only get past this return, this if block, if something changed. And then I think we're going to iterate through that as a bitmap. So we can just say well, let's make this mutable for one thing. We're going to say for, I need to know a key index. Key index in 0 to num keys total, right? Right. As use size. Right. And then we're not going to use this anymore. So rather than doing this, we're going to take a slice out of, yeah, we're going to take a slice out of self dot switch LEDs. Switch LED colors. 0, whoop. 0 to number of keys per side, right? Autocomplete not helping me. Oh, there it goes. Num keys per side as use size. And then I just want to iterate that, right? Why does it not like that? Oh, I don't need the borrow there. Oh, it actually needs to be copied? Okay. I guess it needs to be copied. So, dot copied. Cool. So this will light our switches, but we have to light the other guy's switches too. I don't have a message for that yet, but how about we'll handle these switches first. So, but first we need to figure out if the color changed. So, the way I'm going to do this is I'm going to check the lowest bit in keys changed. And if it's set, then we'll look at the corresponding bit in key state debounced to see what the color should be. Then we'll shift right keys changed 1. So this will be like if keys, well, in parentheses, keys changed and 1 equals 1, or not equals 0 is usually safer. Then that means the key is changed. So now it depends on whether it's set or clear in key state debounce. So if key state debounced, actually, why don't we just make that mutable? And then I can shift it right at the same time as we're shifting right keys changed. Why not, right? And then use the same logic here, just check that lowest bit. So and afterwards we can just say keys changed, shift right equal 1. And the same thing with key state debounced. No parentheses there. Okay, and so this is all under a let color, right? Equal this. And then after that, we're going to move it into self.switch LED colors index key index equals color. So there needs to be an else here. RGB 8 new. Let's just go 255s for now. And if it's not pressed, it's all zeros. So it's either white or black. On or off. Okay, so I would not using core iter repeat anymore. All right, let's test it out. Oh, hold on. The wrong keys are going to get pressed. Right, we need that map that I was talking about earlier. And I think this was before the raid, right? I was talking about this. So NP1 is the first pixel in the chain, but it's underneath switch 4, like the diode for it is marked 4, because the keys are in a different order than the LEDs to make the routing easier on the PCB. So the switches go 1, 2, 3, and then left to right, top to bottom for the normal keys, not non-thumb ones, right? But the new pixels start up here and they snake around here and then go finish down here last. So, which is weird that the first switch has the last pixel on it, but that's what it is. So I need to have like a mapping, and it doesn't need to be programmable. It's hard-coded in the PCB, so we can just make it constant, right? Constant key. Let's make it key to switch LED, or key to LED. And the type of this is an array of, I guess, U sizes, because we're using them as indexes, right? And there are as many as we have keys per side. That's not true. Keys total. Because we'll do both sides together. Yeah. And then equals. So here's where we're going to put our map. So here's where I got to consult this guy. So if key 1... its new pixel is 18, and those are 1 base, so that means I need to subtract 1. So it goes 17, 16, 15. Can I put comments here? Thumbs. Then column 0. So then it's, okay, these are actually lined up, so it's 0, 1, 2. I just put these all in the same row. That might make it easy. I don't know how this is going to reformat it, though. Column 1 is 6, 5, 4, so that's 5, 4, 3. Column 2 goes 7, 8, 9, so that's 6, 7, 8, right? And then 0, 1, 2, 3, 0, 1, 2, 3, right. 12, 11, 10 is 11, 10, 9. Zero, 1, 2, 3. So the last one is 13, 14, 15. So that would be 12, 13, 14. So did I get them all right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, cool. So this is all left. So we're going to have a copy for right. It's cool how you're coding keyword with the same keyword. Yeah, I know. When I had bugs, I would sometimes screw up the keyboard I'm using and have to go down to this other one you can't see. That is my Freestyle Kinesis Freestyle Pro that I got. That's when like we have to admit defeat and say, well, we have to go back to the old keyboard now. Okay, so the first switch on this side is 19, right? Yeah, so it's the thumbs again. 35, 34, 33. Okay, and then column 0. Switch 22, right? So 19, 20, 21. So it's 18, 19, 20. So that means, yeah, that this will be 21, 22, 20, so 23, 22, 21, right? And then it counts up again. So 24, 25, 26. And then again it counts down. 29, 28, 27. And then last one counts up, right? So 30, 31, 32. All right. And it did 4. Actually, that's not too bad. Why is it give me a big warning? It's never used. Okay, well, we'll use it in a second. It didn't put the comments on the right lines. How are we going to fix that? Probably like this, actually. I can just do this. Ah, I'm so not used to my own keyboard. It's embarrassing. Column 4. I have to think about what key to press. If I stop thinking about it, I start to make more and more mistakes. Alright, that's good. So key to LED is what we're going to reference here, actually. Key to LED, index, key index. So there's where we do the mapping. What is this telling me here? The loop variable key index is only used to index key to LED. Consider using an iterator. Key to LED iter mute take? Nah, bro. Nah, I think we're going to suppress that warning. That would make it totally unreadable. So where is it saying the Clippy warning for this? Warn Clippy needless range. It's not a needless range loop. Screw you, Clippy. It's totally to be allowed. Alright. Looking forward to the Rusty monitor stream. Oh, where I work on the GUI for the changing key mappings. Or are you talking like a monitor where I build my own television screen, my own monitor stream? Because I don't know if that's ever going to happen. Technologically speaking, a keyboard is really one of the simplest parts of your computer. Whereas a monitor is one of the most complicated ones. Make your monitor program while using it. See, you're going straight to the hardest thing. How about instead we do a mouse? And then we use the mouse to edit the code that we're doing for the mouse? No? Maybe not as impressive. What if we made a computer and then programmed the computer with the computer? Start with a plotter. Yeah, true. Probably easier that way. Alright. Is this correct? This is only going to write the first side, but that's fine. I'll do the second side if this works. I think this should work. Maybe? So when you said monitor, I thought you meant this, because I call this the Rusty Keyboard Monitor, because it's the monitor program. Monitor is the log stream from the keyboard. So we can see that it's actually programming correctly. A, B, C. Oh, program is smaller than it used to be. All right, so that lit up when I pressed it. It's working. The keys are lighting up as I press them. Look at that. And they're all in the correct keys. You guys can't see it as well, maybe, but I can see it. It looks neat. Beep, beep. That's so cool. I could play with this all night. So now they're lighting up white as we press them. Okay, but the ones on the right won't. Oh, no, the ones on the right do. Hold on. How's that possible? Oh, wait a minute. I thought that this function was only performed by the left-hand keyboard, but I was wrong. It's actually performed by both sides. Okay, then that changes a few things. We don't need the right at all. Yeah, because those are mirrored, we can just do that. And then this becomes number of keys per side over 2. And so does that. And then I can just do that iter straight. This turns into that. And we have to have a matching in it. Cool. So each side is in charge of their own colors right now. I guess that makes sense. Make sure that this is correct. It didn't screw it up. 2 at the same time? Okay, here we go. There, 2 at the same time. How about all of them at the same time? Rah! Okay, you can't see it because my hand is in the way, but rest assured, all of the lights are turning on at the same time. Whoa! It all opened a whole bunch of applications at once. Okay, remind me never to do that again. Never to mash the left-hand side keyboard. It like launched a whole bunch of programs. Okay, program. Watch this thing again. Okay, that's significantly easier than I thought. So then the last step is to implement that algorithm I was talking about, where instead of just lighting up white while I press it, we'll have like an energy level per key that will add a constant amount to every time we press it. And then depending on the energy level of the key, we'll pick a color based off of from a equation or a curve, and then we'll have to like decay every certain amount of time. It even opens all your office productivity because it's so powerful. I know. Face roll unit test success. Hey, this is significant, so I'm going to check it all in. Significant milestone, so it deserves a commit, right? So light up, and look, they're even lighting up as I'm typing. Light up keys when pressed. I'm like distracted and looking at my fingers as I'm typing because I'm like, wow, it's really working. All right. So, yeah, the final step would be to go into keyboard, and instead of this being an RGB value, make it some kind of energy level. Like, I don't know how, let's just go U32 for now, because we'll have to play with these numbers, right? So, we'll be adding energy to keys, to switch LED. This isn't colors anymore, is it? This is switch LED energy. Save everywhere. So we'll be adding to the switch LED energy some number every time you press it. And we'll be like subtracting 1 from everything down to 0 at some regular basis. So that means I'll need some kind of timer. So why don't we just implement that, and we'll have another function like decay or something. Actually, you know what I should do is take this one out and refactor it right away. Well, I have compiler errors, so I can't read the automatic refactoring stuff. So we'll just cut and paste. Next best thing, right? function like send or change LED colors, update LED colors. This has to be mutable self. You want to take a look at the OK Lab for smooth gradients for that energy fade animation? Never heard of OK Lab. I was just going to go with something simple where we pick some anchor points like green, blue, yellow, red, and then just interpolate between the two. It's a perceptual color space with good linearity for linear interpolations. So you think that just if I do a linear interpolation ignorantly or naively, it won't look good? Or it looks even better with a better gradient curve? Guessing it lowered encoding quality during a burst of activity. How did we lower encoding quality? Ever since that face roll, the stream quality has suffered, but it seems to have recovered just now. I haven't dropped any frames. I don't think any OBS key was hit, but you never know. Maybe it's just the internet behaving differently. Okay, so we want to call this here. Definitely, right? Oh, I also want to make this a constant, so let's define that up here. Constant LED brightness. I believe that's a U8. Alright, put that down here. So we'll have to do our map down here to get a color. So why don't I just do that now, like map. So we're going to map some energy to a color, right? So I'll just put a placeholder for now. We'll make it white. If energy is greater than 0. Actually, this can be an intermediate step. We can just have it stay white for a certain amount of time and let it decay down to 0. Yeah. Too lazy to type this, so I'm just going to do this. It's borrowed, so let's unborrow it. We had no colors in the beginning. All we had was the phosphor afterglow from the X-rays, yes. That's right. We weren't emitting light. We were striking phosphorus with electrons and having them glow. Sounds like a job for Sign. The OK Lab blog post shows it's in comparison with other color spaces for gradients, depending on the color space. Okay. Yeah. That's probably how I'll polish this in the end, is to look at something like that. Alright, so, right. So instead of equaling a color, I think what we want to do is we just want to say if... Do I even need the keys changed at this point then? Yes, I do. It's if it changed and it's a 1, then we're going to add some energy to it. How much energy we add, we'll make that a constant, because we'll be playing with these constants, right? Energy per strike. Make an impressive name for the constant. U32. Can't type 32 for some reason. Ultimately, this will be like, starting out, it'll be the number of intervals it'll take to have it go away, right? So let's make it something like 10? I don't know. And yeah, I'm going to take this one suggestion and combine the two ifs together. And then we're going to do a decay where we subtract, was it saturating, subtract down to 0 of every LED switch energy, and then call update colors. And why don't we just put it here? So like decay LED colors. Like, I gotta slow down and type the correct keys. Okay, so for, well, it's gonna be self.switch LED energy.iter_mute. For each, right? For energy in. Well, energy equals energy dot saturating sub, right? Saturating and numeric bounds instead of overflowing. So it's just going to be saturating sub 1. Ugh. Get out of my way, pop-up window. And then self.update LED colors. Let's make this specific. DK switch LED colors, and then this one too. This one needs to be public, but not the other one. I could also build the timer stuff into this, so we can say only if the timer's ready. But we'd have to declare that timer somewhere. Okay, right, so the energy starts out at 0. Use powerful verbs. Exactly. You misinterpreted the goal? No, you interpreted it correctly. Timer, where are you? We have a timer somewhere. Where is it? That's not it. That's dot counter. Isn't it like countdown or something? Gosh, where do I use a timer now? Oh, here it is. What's the type of this? Countdown. Right. I think I'll just build it into this run. We'll do it in the loop, I think. That's the easiest. So I mean, we can do it at the top. Why not, right? So yeah. While we're setting up the other timers, let's just set up another one. Set up a timer to decay key energy. Let mute switch key energy decay. Powerful words. Timer. Timer's powerful, right? Timer dot countdown. Duh. Slow down. Type the keys I want to type. There we go. So here's where we put the interval in. Let's make it switch key energy decay interval. I guess milliseconds is fine, right? Dot milliseconds. All right, so I need to define this extraordinarily long named constant somewhere. Let's put it at the top, where all of my other extraordinarily long constants are defined. This is the longest yet. It earns the prize. How come I can't type 4? I don't know. It's getting late, I guess. It's not even that late. It's only 9:30. Okay. So if I had it to 10, it really only needs to be as often as we would perceive it. So maybe like 100 milliseconds. Right? So every 100 milliseconds will decay the keys a bit. I probably want to do it more often, actually. How about 50? Okay, so then here what we do is we say if switch wait if let okay. I think that's the way this works. That means that it has reached an interval. Then we'll do self dot decay switch LED colors. There we go. This needs a semicolon. Milliseconds. Hold on, what? Oh, it can't be a U64? What was the type of that? U32, okay, fine. 32 it is. Mode equals input. Hello world. How's everyone this lovely day evening? Output. Doing well. Thank you, CodeCat. And good morning, Tribute Dev. Or Dr. Padawan, I mean. And you're just a bit. How are you doing? Look, I got the LEDs all done. They light up whenever you press the keys. Now I'm trying to do something more like what I want to do eventually, which is where as we type faster and faster, it gets hot like a heat map, and then take my hands off the keyboard and it'll decay. But we're going to first start off with just white, and then we'll put in some colors. I promise. Let's just make sure this builds. So if I did this right, every time we hit a key, it'll add 10 to the energy. And then every 50 milliseconds, it'll subtract 1. And when it gets to 0, it turns off the key. So I'm not even thinking about if the interval's correct. I'm just going to see if it works. Because that's how I roll. Could you type 4 before adding the cap over the microcontroller? It peripherally seems like an extra column of keys. Yeah, I don't actually look at the keyboard as I'm typing, so I don't think that's throwing me off. I think I'm just used to the corn configuration, which is the stagger is different, and I'm just ending up hitting the wrong key because I'm not used to this yet. Going to implement a smoothing function? Yeah, like some kind of interpolation, yeah. I'm just going to pick something easy. Should make some stats so you can output some daily, weekly, monthly stats on how fast you type, what keys you use, and how you use them and such. I was doing that when I was learning the Colmac layout. I was using monkey type stats, but I found that it only kept the last 1,000 tests, and I was doing way more than 1,000 tests. And I kind of lost the history I'd been accumulating, so I kind of lost my momentum there. Let's just hide this. So if I press a key, oh, that's cool. So it stays lit for a little bit, and then it vanishes. So if I mash a bunch of keys, see that? Cortana tried to pop up. Oh, the run box popped up. Yeah, I have to be careful about face rolling in here. If I just avoid the key on the right, it should be okay. Look at that. Cool, what if I hit the same key a lot of times? So like... That's cool. Alright, I like it already. Let's check this in. I'm having too much fun. Programming shouldn't be fun. I'm having too much fun. Okay, so now we're key presses build up energy. Light LEDs. Okay, this is too much to type. So that's going to be the next line. And that's going to be a complete line. Light LEDs, white if they have energy. Make energy decay slowly over time. Okay, so this is, I don't know, better key lighting. You don't know from fun. This is responsible. You also fixed your COM port issue. Apparently you deleted a while one at the end of main, so it was just stopping all execution. Okay, for me, it's in the middle of setting the line config. It just pauses, and I haven't figured out why. You get out of control fast, yeah. Should make some oh, right. Not a hint of red. Hold on, wait a minute. It didn't say anything was wrong. Your code physically would not run, but it wouldn't tell you what the heck was wrong with it. No error message, not a hint of red, even less in the idle, nothing. Stuck on an error for reading a file. So what was the problem in the end then? Because that's really frustrating when it won't run and the tools won't tell you why. That's got to be really frustrating. Okay, so back to switch LEDs. So this is the module we can focus on now. So my idea was I wanted to add some control points. So like when you first, when at a low energy, we want it to be like dimly like purplish blue. But let's define this data structure. So I guess it can be an array, right? Seems fun to have your code do something a little bit more tangible. As a game dev, for you would always exist within virtual spaces. Yeah. So having made something physical, there's a bit of like a feeling of reward. Especially when I got all that soldering done. I'm like, wow, and the lights are working. I'm like, I did that. Yeah, it does seem fun to program hardware. But you have to avoid real disaster, like burning things up. Okay, so what are we going to call this? Like, key, well, energy, a color, control points? Sure, that's as good a name as any. And that's going to be, this is going to be an RGB 8 of some size of, I actually don't think I can make a constant, because, yeah. I think what I need to do is have a function that makes this, and then stash it in the keyboard. Yeah. So we'll make a function that does it. Make switch AD energy color control points. Well, I need some of that. Not a lot of this stuff, though. This part. Oops. So, how many of them do we make? So, blue, let's just go simple. Blue, green, yellow, red. So 4 of them. Okay, so the first one. Blue. Ugh. Didn't mean to open a terminal. I have the wrong thing in the clipboard. Now I have the correct thing in the clipboard. Okay. And then green. And then yellow. Yellow is what? Red plus... I can't remember. Is it red plus blue? No, that's violet, right? So yellow would be red plus green. And then finally red. Red will be like red hot. There we go. The gradient. Well, I'm going to interpolate between these colors, so it's going to change the hue. I think that's fine. Actually, you know what would be better is to have it start out at 0, 0. So it'll grow from dark to full blue, and then switch to green, switch to yellow, switch to red. And maybe we can change the intensity as it goes. Let's just start with this. So there are 5 of these now in there, right? What did it do when I had 4? Was it not an error? It is an error. I'm contemplating making it a vector so I don't have to say the constant 5 there. Actually, I am going to make it a vector. Because then I don't have to carry around its size everywhere. I could probably do it with the const generic, but I don't feel like it, so I'm cheating. Put it on the heap. So vec is alloc vec, right? Alright, cheating. So keyboard init will have something called that. How about we just name it that? An extremely long name, which is a vector of those things. So back in keyboard, I don't think I have enough member variables. Let's add more. RGB8. There. I did not make it public. Now. Oh, I have to say self colon colon. There we go. Because it's a class method. It doesn't have a self in there. Programmer never makes mistakes. Their code works precisely as it's meant to. Okay, so I need to decide, like, the span per gradient. I could build that into this, couldn't I? I'd rather just leave it linear, so then we'll have a constant for span per control point. Yeah, let's say energy per control point. Let's make it like 30. So you'd hit it 3 times to get it to full on blue, hit it 3 more times to get to green, 3 more to yellow, and then 3 more to red. And it's decaying. I'm gonna have to adjust the decay rate and all that stuff. Anyway, let's see how this goes. So it's this map that we're ending up changing, right? So it's going to be self.switch energy control points indexed by the energy divided by energy per control point, and then we need to cap that, right? So it would be the minimum of this and the length of this minus 1. Actually, the way it's done in Rust is that length minus 1 there. Min comes from core compare. And then I have to do a copy, right? Cannot be, okay, so we have to convert it to, as a usize. They'll do the usize up here. Ugh. There we go. There. Sloppy, but it'll do, right? Actually, what am I doing? That's just going to pick one color or another. It's not going to do the interpolation. But, okay, we'll do the interpolation after we make sure that this works. This should pick the correct control point. Then the final will be to, like, to pick the two control points, the one lower and one above, and then interpolate between the two. Being self-taught, you never truly grasp a lot of the fundamentals. Same here. Such as the specifics of what goes on the heap and the stack. You should research that at some point. There's actually a simple answer to that. What goes on the heap are things that you allocate dynamically. In Rust, that would be box, and anything that uses box or something that is boxed. So like vector or any of the other containers. We'll put all those stuff on the heap. Everything else is on the stack. In C, it's everything is on the stack except for what you call malloc for. So some languages is actually pretty straightforward what's on the heap and what's on the stack. Anyone else have that one piece of software workspace you have that can only be described as your mind palace? Mind palace. I can't say that I do. Okay. Yeah, it's rounding down, but look, if I press the key enough, it turns red. And then it decays to yellow, and then green, and then blue. I should probably cap the energy, right? Otherwise, if I press this enough, it'll stay red for like a really super long time. In fact, it might overflow U32 at some point. If I type for years. Okay, definitely we need to do the interpolation. Use a place in World of Warcraft? Really? In Python, would stack versus heap mostly be mutable versus immutable types? I think Python, it's harder to say what's on the stack and what's on the heap. It's actually not true. Boxed arrays actually end up on the stack? Really? You found out at one time. How is that possible? How did how does a boxed array end up on the stack? I thought boxed by definition means it's on the heap. Am I wrong? If I look up actually go back, go to docs and look up box. It is a pointer type for heap allocation. So you're saying that there's a caveat to that of some kind, that actually if T is an array, it might not be on the heap? You box something by calling box new and passing the data. Sure. Oh, so there's an optimization to this that it could actually be on the heap, even though it's all about heap allocation, or on the stack, even though it's about heap allocation. The data has to already exist before allocation. Yeah, true. Except for when it's not, and there's a special case of that. And where did I do that? I forgot where, but it's possible to actually allocate something on the heap without it being on the stack at first, but you have to go through an unsafe construction for it, because it has to be like uninitialized at first, and then you in place construct it. I forget where I did that though. How are you doing, Sarian? See, we talk about Rust, and then Sarian wakes up. Okay, see ya here just a bit. I'm almost done. I just need to do some interpolation here. So what we're doing when we divide here is we're rounding down, right? So probably what we want to do is switch to floating point. Do we have floating point on this? Actually, I don't know if we have floating point on this. Have we used floating point? I think I have in the logger, right? Didn't we use floating point? No, we didn't. I don't know if we have floating point on this. We could do fixed point math, I guess. Well, I guess we'll just, yeah, just for safety, because I don't know if I have floating point. I'll do fixed point math. So that means we want to, if we want to cap the energy, why don't we just calculate that? Max energy. It's going to be energy per control point times the number of control points. This one. Okay, and then we should do the max right away of that. So let energy equal, and this is a reference, right? Yeah, so it's going to be min of energy and max energy. Okay, and then let's say energy Q8. Shift left 8. So Q8 means it's a fixed point with 8 bits of decimal. So then when we divide by energy per control point, so that would be, well, it would be point. Well, point on curve, I would just point. Q8 equals energy Q8 divided by this. Okay, and then we're going to interpolate the red, the green, and the blues between that, right? So that means we need to get the two colors. Energy 1 or 0. Well, it's point. What am I thinking of? Obviously just N0. Q8. Shifted left 8. And then let N1 equal... I have to think about the limits, though. This max energy, if it's at max energy, it's going to end up... If I can't just do N0 plus 1, can I? Because it'll go beyond the end of the array. So we have to have a special case for if the energy is at the max. Actually, why don't I just do it here? If energy is greater than or equal to max energy, then we'll just go down a completely separate path. And then I don't need this min. Right? Ugh. Type the correct letter, Ramu. Okay. Yeah, then it's always the last one, right? So can we just say dot last? Dot unwrap? Okay, and then otherwise it's RGB 8 new. And then we have to interpolate the red, the green, and the blue. So it would be N0 dot I thought it was just R. How come it's not auto-completing for me? Probably because I have all these other errors. Oh, because this has to do copied. It's not an iterator. Wait, does last... When in doubt, make a variable. What is X? A reference to an RGB U8. Okay, so then dereference? Right, because it's copied. Yeah, okay. Sometimes I just need to see the type to know what to do. Assuming RP2040 float ops are handled by ROM code. I don't know if they're handled at all. Sometimes the optimizer can change things so that allocation happens first, then initialize the data in place, but the optimization fails. If you recall correctly, Rust has a floating point emulation library for embedded that'll switch to. Yeah, but when you're embedded, sometimes it's best to just go fixed point. That's what I'm gonna do. Cannot be indexed by U. Okay, so this should be like as U size. So the auto-completing parentheses is more trouble than it's worth for me. Oh, this one I don't need to convert because it's already the correct type. Okay, cool. So then linear interpolation would be to add the 2 and divide by 2, right? I think, yeah. Probably a smarter thing to do here would be make a lerp function that does this for me, but I'm too stubborn. Should have, oh, okay, fine. It doesn't like how I named this. Picky. Well, we'll see if it panics or not. Before fixed for most arithmetics, but there's some fun bit fiddling that works well with floating point, yeah. Humans don't care 99% of the time because the CPU is designed that way. They're tin spin. Oh, what did I miss? Link to muffplib. Okay, so I guess there is ROM code for it? In the boot ROM. Huh. There was some reason why I chose not to use floating point in the logger where it computes fractional seconds. Maybe because I knew it would just be faster to do with integers. I know I got floating point to work on the Raspberry Pi Zero, but I had to do some special setup for that. And maybe you're right that the Boot ROM does that too. We are programming. Oh, thank you for that post, because I want to look at that later. Oh, they're all blue. Does that mean it's not interpolating from the right spot? Well, they're all blue. We'll have to deal with blue keys for a bit. See, this is where bugs become fun, where the bugs are in your keyboard that you're typing with. Suggestions and links from chat. So this is CUDYN. Take a look at that later. Thank you very much. I just want to get something really rough going. Hey there, Everx. How are you doing? First info box shows the difference between HSV and HSL quite nicely. Okay. Okay, I want to see right now, if I hit this key enough, does it change color? Oh, it does change color, but I don't think the interpolation is correct. Yeah, it's definitely wrong. Okay, I did something horribly wrong in this code. Right here. What did I do wrong? So if it's at max energy, we just pick red. Can I verify that here if I just press the keys enough? It's just stuck at red. Another... It actually crashed the keyboard. Okay, so we have a... Yeah, it crashed. Let me get access to that reset key for when it crashes again. Yeah, it's crashing, so if I reset it... Yeah, okay. Okay, we have a crash here happening somewhere. So maybe this is... So... This is correct, right? There should be a last control point. And it should be red. Okay, so if the energy is... Let's say the energy is 0. 0 shift to the left, 8 is still 0. And then divided by that will still be 0. And then shift to right, it'll still be 0. Oh, wait, I didn't do the interpolation correct. We have to, like, multiply by a weighting factor of how close it is to 0 versus 1. So that's like the lower 8 bits. Right? Yes. Hey there, 715209. First time coming in here, and is that you're making the sound effects? No, I made one sound effect, which is the bada sound. Bada. Just so that you don't think that it's your computer making that USB connection sound. Because it happens quite a lot on the stream, because I'm working on my own keyboard here. No tropical beverage? I'm out of beer. I need to get another one. 7 a.m. fresh coffee? Well, for me, it's the evening. I should just get myself another beer. But I'm hopefully near the end of the stream. I'm just trying to get my keyboard to light up the correct colors as I type and not be stuck on blue. Yeah, so I should get the fractional, right? F0 equals 0.Q8 and well, I guess I'll just type it in 255, right? And then F1, well, actually, I think that's usually called alpha. Right? Because then it's going to be this times alpha divided by 255? 256? Times alpha divided by 256, I think. And then this one will be... so I don't want to do a divide by 2 at all. I don't want to do an average. Average was wrong. This would be times 256 minus alpha. Or do I have this backwards? I think I have it backwards. So why don't we just switch this to a 1 and then switch this one to a 0. Then it's correct. And this should be 255 minus alpha, right? Because a 0... No, it would be 256. But then I need to divide again, right? Right. I should probably add them and then divide the total by 256. Okay, well, when I get this working, I'll do the green and all that. What type is this? U32, and let me guess, that's a U8. It's a red. Component type? Oh, I guess I don't want to do dot red. I want to do, oh, it is a U8. Okay. As, U32. Man, that is ugly as heck. And then, yeah, the whole thing... The whole thing as U8. Wow, that's messy. And I'm gonna copy this bizarre mess twice. That's how bad I am. And I'm just gonna change it to G and B. This is a horrible mess. But is this correct now? It's the right control point times the alpha. So the alpha's between 0 and 255, right? So this should actually be 255 as well. No. It shouldn't. Did I grab a beer? No, I didn't. That beer's empty right now. If you add them together, shouldn't it be divided by 512s, given that each could be 255? Well, one's alpha, one's 256 minus alpha, so that should add up to 256. So I think that's correct. Right, isn't the lerp function? Let's look up the lerp function. I should have just done this earlier. This is the general form of a lerp function, right? Oh, that's a different way to do it. Start plus n minus start times percent, or that alpha thing, right? I thought another way to do it would be start times alpha, n times alpha plus start times 1 minus alpha. Anyway, it's the same thing in math, right? This is probably wrong, but I feel like trying it out. I should just make a lerp function and call it 3 times, shouldn't I? There's a lerp trait, so it might be worth it. Is there a lerp trait? Why would you need a lerp trait? Hey, look, they're back to black. Oh, I think it worked. I think it's working. Except it crashes still. Okay. It's good except for the eventual crash when energy fills up too far. So I gotta look for the crash point. I mean, I guess it could be where we go out of range here. So if it's almost at max energy, won't it be like... Am I thinking about this wrong? Like... This will be the point to the left, and this should be the point to the right, right? We shouldn't go out of range. Perhaps lerp for both F32, F64. Lerpy lerp. It could be this unwrap, I guess. Returns the last element of a slice or none if empty. Well, actually, I don't want it to be a slice. Okay, let me just fix this. Not fix it, but express it differently. I want the last thing in the vector. Dot len minus 1. It doesn't like that y, because it cannot be dereferenced. Alright. And maybe there's something wrong with the way I did last and then unwrap. Unwrap is a crash point, right? So, program. Oh, I need to remember to cap the energy. I guess that means I could cap it in a different place. Rust never promises no crash, it's just memory safety. Yeah, unwrap is a place where you can crash, right? At a panic. Also, whenever if I have some math that's going out of bounds, it could be crashing. But these are U32s, right? And that's a U size, which is going to be at least 32. I mean, when we go down to U8, could that be a problem? I don't think so. I don't know. But, alright, let's try again. It crashed. Right when it gets up to max energy, or near max energy. It looks good to me, except for when it hits max energy. See what I tap, tap, tap. Oh, now it's getting hotter, and now it's decaying back. Gets hotter, decaying back, till finally it disappears. It actually looks really good. But what's wrong with max energy? That shouldn't crash at all. So it must be in this else part, right? Like maybe when it's approaching the max? Maybe it's when adding that when lerping down. Well, we do convert it. These are U32s, right? So it shouldn't overflow. This add won't overflow. I'm thinking like, well, as U8 doesn't overflow, does it? Or as doesn't panic. I forget what as does. Like it wraps around or something. Or does, I can't remember now. Does could as be panicking? Okay, maybe it's in this one. No, that didn't have a problem before. I don't know. As U32, as U8. Okay, I feel like I should at least pull out a lerp. X or val. Actually, let's just leave it as U32. N0, U8, N1, U8, and alpha, U32. U32. Or, yeah. So that's, there's no val. What am I talking about? That's N1, that's N0. And this is N. Oh, I got them backwards, didn't I? N1 and N0. Logs everywhere. Yeah, but if I log and it panics, I won't even see the log message. Wrapping only happens in releases. Debug build. It has. Well, I'm doing a release build. Taking your averages wrong, going out of bounds with multiplies, or doing. Yeah, that's what I'm thinking. I must be doing something like that. Doing something in the wrong order or something. But maybe it'll be obvious if I put it into this form. So, right, this is lerp. I should order it N0, N1. Okay. So 0 goes there. The name is too long. That's my problem. I need a shorter name. G, and B. How about we just call it energy control or energy points for short. I'll refactor this later. Save everywhere. Okay, what did I do wrong with my lerp? Oh. Free function. Be free. Zero to 1. I'm just worried if this is going out of bounds. But I'm thinking like, if it's max energy -1, then this will go back to well, let's take the simple case. Max energy. Let's say there's only 2 points, so that would be 2, right? Then it's 2 times energy control point. So then, let's say that that's 10 or something. So that would be 20. So max energy 20. So then if we're not greater than or equal to it, we're like at 19. So then 19, shift to left, up 8. Divide by 20 and then shifted right again. I think I need a calculator for this. So like 19, clear, 19 times 256 divided by 20 divided by 256. Right, it would be 0 because this is an integer, right? And then the n1 would be 1. So that should work. You do clamp on the +1 and see if it stops the crash. I just don't think that that's it, but I mean, maybe it is. I don't know. So N1 as U32 times alpha plus N0 as U32 times 256 minus alpha. I wonder if that needs to be 255. Maybe that's the problem. Alpha could be 0. Alpha, the range of alpha is 0 to 255, right? So this would go from 1 to 256. I think that's what I want. I don't know. Let's see if it works. Math is hard for me. We'll put in clamps if this doesn't work. I'm pretty sure it won't work, which means I'm destined to put in clamps. Well, that's programming. How do I put in a clamp again? Is it just clamp? I guess it would be this one. Ah, yeah, okay, fine. So like right before we do, go back to U8. Okay, got it. It's programming. Ba-da. All right, and then just hit this key. Oh, hit a key that we can actually see. And it crashed. Let us clamp. Ba-da. Beep beep. Ah. Clamp 0 to self energy points len -1, right? Actually, I need to look at clamp to see if it includes those points. Returns max if self is greater than max, and min if self is less than min, otherwise it returns self. Okay, so that's exactly what I want. So just one at a time until I find out which one it is. That would be smart, right? Put clamps until the crash stops happening. And then I'll know what I needed to clamp, and then maybe I can find out why the clamp was needed in the first place. So if alpha is 0, you're left with 256, which is out of bounds. No, it would be times 256 divided by 256.
Ba-da, ba-da.
Because, where is that? It'd be whatever n0 is, times 256 divided by 256, so it'd just be n0. So it would reduce to n0 plus 0 times n1. So I think that's correct. Press key until crash. Oh, it's not crashing. Okay, well, so that clamp was needed there. And it's taking forever to decay because I pressed it too many. Oh, there it starting to decay now. Okay, so why do I need to clamp it there? Where am I? Where am I? Where am I? Where am I? There I am. How could this be getting out of bounds? I thought I had a greater than... So it means energy must be less than max energy. So how are we getting... out of bounds of energy points. Again, max energy is that. Alpha 0 left to 256, which is out of bounds, would be, it would be, what's 1 plus 1? I'm not sure. This should be the point to the left. If it's either, so, point is either going to be some number, right? This is going to, alpha is going to be some number between 0 and 255, right? And if it's 0, that means that n0 is right on, it's right on that control point. And we can't be right on the last control point, can we? Oh, does it need to be that -1? Oh, yeah, it does, doesn't it? Doesn't that need to be -1 right there? Is that what you guys been trying to tell me? And then you've probably been yelling at your screen saying, you have to go to -1 of the length, not all the way to the length. Because let's say there's only one control point, then we want the max energy to be 0, right? And if there are 2 control points, then we want the max energy to be 1 interval. Yeah, I think that's it. Let me test that theory by not clamping this one at all. Maybe at a control point max variable. Yeah, I do a -1 in too many places, you're right. I'll refactor this in a little bit. You know what would have helped me listen to chat more and get this working sooner would be another beer. All right. And we reach red and we're not crashing. Okay, so that was it. So I don't want the energy to actually build past that point in the first place. So I kind of want to move that max. I kind of want this to be calculated when energy is added. So that is up here, right? Where is it? Right here. Well, what am I doing? It should just be, no, it's actually exactly that. So let's first borrow this. Min. It's entirely not what I wanted. That's what I wanted. Hold on, I missed a whole bunch of chat. Ah, brilliant idea. Hey there, Phil Powers. So it isn't a single scalar value for energy, but a series of power levels. Well, it's like I have these control points and we're interpolating between them. So at 0, that's 0 energy, that's max energy. And then somewhere different levels between, but like it should fade between these, you know. That's what that's what I'm trying to do. And min needs to be imported, and this needs to be dereferenced. So we're getting access to the energy. We're computing what the max energy should be. And then we're capping it at that. Would it be better to do a clamp here? I don't think I need to do a clamp because min is good enough, right? Okay, then I don't need this at all. I think we're good then. Let's test it out. Build that sucker. Hot take, but U8 max is better than 255. Well, it's only a coincidence because I did 8 there. It would probably be better for me to just have that be a constant, like number of energy sub intervals, right? Or number of basically we're interpolating 256 points between control points. Why do you need to compute the max energy every iteration of the loop? You're right, I don't. Good point. That could go way out there. In fact, that could be a const. No, it can't be. Can't be const. Because we don't know how long that is. Yes, good point. Yeah, so it's only because the coincidence of that being an 8. If I put a 9 there, then there's no U9 max that I could use. Num lerp points with assert that it's a power of 2. It is true that I am I've baked in that number here, but what if I make it a constant? So energy subintervals. $32, I think. Well, energy subinterval bits. Eight. And then subintervals is 1 shifted left that many times. Sorry about the cursor shifting so unexpectedly. Okay, so then we can use these 2 constants in all the places that we need to, so that's 256. So this is really not suitable for any kind of lerp. It's lerp energy. Lerp energy. Okay. Then this is that, and this is that, and this is actually that -1. There we go. U32 seems tremendously expensive. The problem is that these other values are already U32. So if I don't make this a U32 itself, then I'll have a whole bunch more as's when I'm doing this math, right? So U32 is just what we're choosing to be our type while we're doing this arithmetic and shifting and adding and stuff, right? And we're only converting to U size when we need it to be an index, and a U8 when it needs to be a value, because that's what RGB 8 new takes. It takes 3 U8s, I think. Well, it's just generic on some T. Actually, how do they do that? I don't know how they do that. I think because RGB 8 is RGB with constant. It's a that's a constant, right? Not exactly. Where do they do that? Where's RGB 8? Yeah, U8. Automod hated your message indeed, but I permitted it. So one feature you like about Zig, auto-synthesize log bits type for shift amount? I'm used to this stuff. Oh, we have a warning. Unused? Oh, unused parentheses, unnecessary. I think I might need to add another control point for another red, because I want things to stay red for one control point's worth. Because right now it'll get to red and it'll immediately go to yellow. Or it'll immediately start cooling off to yellow from red. But I think I would kind of want it to stay red. In fact, I think I might want it to go to a brighter red. I don't know. I haven't decided yet. Nice to get a compiler error on overshifting values, yeah. It's always better to get a compiler error. And second best would be a compiler warning. And third best would be a lint warning. Fourth best would be improper behavior that you have to figure out. Okay, hitting keys, it's heating up, and it's orange. Oh, we crashed. Okay, I introduced a bug. Let's find the bug. It's right here. Max energy? No, we took the -1 in there. Just use the UB sanitizer. C++ programmers, exactly. Unfortunately, I don't see where I introduced the problem. Are we going back to clamping then? Well, hold on. Because this is one thing I changed, right? It should never get past max. Oh, that'll be one. That's exactly 1 unit over. I need to subtract 1 from that. Right? Actually, while I'm at it, why don't I just add that second red point that I wanted? There. I did it. Totally irrelevant, but just want to check you understand as you don't do any rest. Why does the types need to be number left shift bits as U32 shift left U32? The shifting I'm doing is to make it a Q number, like a fixed point, not like an integer where the lower 8 bits in this case are fractional bits, so that I can do math and in the end I'll have like a fraction in this alpha, a number between 0 to 255 that says fractional, like how distance between points n0 and n1, right? So that's different from the as's. The as's are doing typecasts between different types of integers. So indexing into a vector or an array or a slice always needs, the index has to be a U size. So it started out its life as a U32, so we had to turn it into U size. I think the only other places we're doing as now is here, because the RGB values are 8 bits, but we need to boost them up to 32 bits to do this interpolation, and then when we get the interpolated value we go back to U8. But that should be the only places where we see these as, and so the shifting is different from that. As far as you can see, shift left implements shift left 8. Oh, you're saying that I didn't need to type, are you saying that this doesn't need to be a U32? Is that what you're saying? That this could be a U8, and so could this be? I just left it U32 because the other types involved are U32s, and I didn't want to mess with two different types. So maybe I'm wrong. Maybe this could be a U8. Actually, let's just see. You're saying that I should be able to get away with this, right? Well, not that, because that needs to be at least 9 bits. Well, I think you're right, because it's still compiling. Yeah, so the number of bits can be a U8. It didn't have any problem with that. Right? No warnings or errors. But there's no really need for it to be anything other than the other types I'm using. I'd rather not even give a type here, but I have to. If I have to give a type, I'd rather have it be the same type as the other values I'm using, for no real good reason. Yeah. Okay. If this works, I think I'm done. Until I think of another challenge to do with this keyboard. Wow, I'm really honored that 74 of you are still watching me, even though I've been beating this thing to death. Only reason to shave U32D8 would be if you're working on firmware which eventually runs out, but no reason for premature optimizations. Well, still useful to think about if there is a reason for it, but yeah. Sometimes you can find a reason and it's like, okay, then you've justified it. Or, okay, lab, unfortunately it will be a challenge as it uses some floating point math. I mean, maybe we have the floating point processor in this and I just don't know it. I just didn't want to go down that rabbit hole, so to speak, right now. Okay, oh, why did I undo? I don't know. New file. Tap, 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 tap. We should get up to red. And it should stay red. And then, okay, and then decays to yellow, and then green, and then blue, and then it fades away. I like it. So if I type long enough... Beep, 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 beep. Whoa. Beep, 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 beep. What did I learn from the last face rolling? Not to do it again, right? And yet I did it. If I stick with the top row, none of those are hold modifiers, right? Oh wow, why is it so far queued? What the heck? Does my keyboard have lag in it now? Wow. I wonder why there's so much lag in my keyboard. Huh. I do have, an output cue now that I did off stream, and that was to make it work on the Mac where I had to cue things and have weights between them. But I didn't think it was that extreme. It looks like it is. Okay, well, not that we're going to face roll that often, but I guess there's a limit to how fast we can face roll. Okay, I think it's decaying too fast, or it's not accumulating energy fast enough. So let me tweak. I need to tweak this. Yeah. I think it is decaying too fast, so... Actually, maybe not. I think there just needs to be more energy per strike. Let's give it, 20? Yeah, let's just double it. Probably those extra 24 bits, yeah. Be cool to have a rainbow scroll across the keyboard when you patch. Yeah, it would be cool, but that would be a lot more work, wouldn't it? Who's gonna write such a rainbow code? How hard would it be to do a rainbow across the keyboard while it's reflashing? I guess it wouldn't be too hard. We could just pre-compute the RGB values and just cycle through them. Next test, mini HTTP server on the keyboard so you can connect and change the settings. While it programs, I guess I'll close up this. I don't need this anymore. Yeah, we should see the rainbow wave going back and forth. Or what if, like, if you don't press any keys for a long time, it goes into an idle pattern of some kind, where it just kind of scans back and forth. Those are the kinds of things I'll think of later. Okay, that's not bad. Just thinking about how fast I might actually type. I don't know, I kind of feel like it's still not... Or maybe it's decaying too fast. I have to compare with my corn keyboard. I think I'll just be playing with this for a while until I get values that I like. Hold on a second. I gotta take this call. Alright, I accidentally had turned on the display capture when I was supposed to be turning off the camera. So anyway. Where was I? I think I'm just gonna leave it the way it is for now. I think I'm happy with it. So, let's check this in and then we'll raid someone else. Let's revert this. You were creating a key logger. Tisk tisk. Oh, what happened with that blank line there? I think this is good enough for tonight. Alright, so git commit. And what am I going to say here? I'm going to say that have keys light up different colors according to energy levels. And that's too long, so then summary line would be neat colors for key energy. All right, I think I'm done. Let's raid somebody. Then I'll take a break. Oh, you're welcome, Everex. Ah, shoot. Quantum Apprentice? Again? Let's go say hi to Quantum Apprentice. Maybe he'll actually stream for a little bit longer. Alright. I think last time I read Quantum Apprentice, he was ending up, and I just had our power went out at our house. Good thing I have a battery backup, and I'm raiding someone right now before I run out of power completely. So enjoy Quantum Apprentice's stream, and hopefully I'll get the power back at my house soon. And see you later. All right. Bye-bye.